All right, welcome back. So with any luck, this will be the final video in the BFD for Bgp topic of the JNCIE-SP exam. I do have a red mark here just because I was playing Oculus Quest in case you're wondering what that's all about. So I will share my screen and get right into it. So we were looking at authentication last time, but I needed to cut the video short because I had to get back to work, but the work day is now over. All right, so where I left off was I was trying to see the, right. So I was troubleshooting this because it wasn't committing unless I specified both the transmit and the receive intervals. So let's see what I actually did specify, if anything. So transmit and receive intervals, okay. Perfect. So you can see when I enabled it under the group, I specified the minimum interval. I didn't specify the, okay, so that must be for both directions. So I think what I'm gonna go ahead and do is delete these three commands here and then configure them under the group, because it looks like when you configure it for the protocol, you won't carry over this command. It's going to be specific to the group only. So, and one thing that might be interesting to check if it's true is that you're going to have this, any configuration applied to the protocol, something that's less specific, will be overwritten by anything applied to something more specific, such as the group or the neighbor. I don't know for sure if that's true, but I really think it is. But we can definitely do some kind of check to make sure that is true, but it might be for another topic for another video, just to be sure, because kind of need to get through all these topics, and you know, this is coming up. Although I don't even know if they'll still be having it. They'll probably just have it remote or something, because normally the way it's done is you've got to fly out to a testing center, and there's one in California is the main one, and then there's one in like something like I don't know, Virginia or something. There's one on the East Coast and one on the West Coast, I think. And you've got to book a flight. You got to go and spend all day, 8 hours, taking the test, and it's got to be proctored, and you're going to be taking it with more than just yourself. I think they don't even schedule it unless there's more than one person who's going to come up for it, because they don't want to kind of have a proctor just give it for every person who wants to take it. They want to kind of group it up. So you're in a room, there's other people working on their own thing. So what I'm doing now, talking out loud, creating a video, I'm not going to be able to do on test exam. I'm not going to be able to talk out loud to myself because there's other people in the room. That's something I'll probably kind of, few weeks before the exam or something, I'll just kind of give myself practice runs as if I were actually taking the exam. But there actually might be differences now with the virus stuff where it's all remote, and I would prefer that anyways. To kind of, I wasn't too excited about flying out to some place that's not very interesting and taking a test and flying back. I would have booked a hotel for the night before and the night after, I think, or just the night before, just because I want to be able to know I can get to the test center. If my flight's delayed, I still want to get there. So that's how I was planning to do it. And then I could probably fly out right after, but you know, even then, it's like, you know, a whole day doing the test, like, and then flying, going to the airport, you know, flying is stressful, not fun. So at least for me, it can make things more stressful knowing I've got to catch a flight. So it's like, just book it for the next day. So it's going to be like a 3-day thing, a day for travel, a day for the test, and another day for travel. But hopefully it's, in light of the virus stuff, it's going to be not as much of a logistical nightmare as that would be. And one of my coworkers did it already, and it was every bit of a nightmare as you would think it is. In fact, he said that the proctor didn't even show up on time, so he couldn't even stay and make up the extra time that the proctor had, because, you know, he had to catch his flight. So it's yeah, it's really just a very difficult exam. And as I mentioned in the last video, and I'll restate here, that you know, it's so difficult that it's one of those things where you might question, oh, why am I even doing this? Well, my suggestion for you is to figure that out before you really start to seriously have those questions. All right, so let's go into the group and apply those same commands, but now at the group level. All right, so we're going to be removing them from the, okay, and that was just part of the commit before. So this looks good. I think this will commit. I mean, obviously we'll need to change the start time, unless it already starts. Let's do a show Bgp summary. And I guess I was expecting it to go into downstate or something. Show Bfd session. So both of my Bfd sessions are still up, which I'm surprised, maybe because it's loose. So show pipe display set, pipe no more. Yeah, so because it's loose check, maybe if one side's configured and one side is not, then it won't bring it down. So let's go ahead and tail out or monitor start on the file that with the trace options file that we've got right here. So Bgp Bfd. So let's do a monitor start on that. And yeah, so you can see when you set up trace options, you set up the file that you read it to. So file list, or actually file, let's see here, where is that file going to be? So it's not going to be here. I'm pretty sure it's going to be show log. And it's going to be pipe grep or pipe match Bfd. Yeah, so you can see it's just in, so here I'm checking, let's see here. So when I check here, I'm checking the roots, but you can see I'm checking in two different places, and it's going to be in log. And let's take a look at the help menu. So this is the contents of a log file, and all the log files are in this directory. But file, that's going to be different. These are file operations. And this lists file information. Let's see here. Well, anyways, if you want to see the file that is created through the results of this command, which is used for logging. You do show log, and you can see where that file is on the device. And then here's the flag, so this determines what goes into that file. That's how we know that we're capturing information about BFD, because we're flagging BFD, and then we're adding more detail. So just look at that a little bit closer. Help menu says trace Bfd events. And then we can get detailed information, we can disable it, we can trace only things we receive, or trace only things we transmit. So yeah, really useful. I probably will set up those for the JNCIE-SP. Just I'm in a menu or something, just set up those, and then I can monitor start on those and really instantly just see what the issue is, and monitor stop to stop the chatting, and then I can have really clear logs. All right, so and then what was the issue again? Okay. Oh, but this side should be fine now, because this was applied only to the, oh, okay, I see. So here we applied BFD only to the group, but then we went and applied it. So show pipe display set relative. You can see it's applied to the neighbor, but it's also applied to the group. But when applied to the neighbor, we didn't set the minimum interval. We only set that on the group. So we're going to have to apply that to the neighbor as well, I believe. All right, so that's compatible. You can have it on the neighbor and on the group, but you can't have configuration on the neighbor and then expect the configuration on the group to inherit down to the neighbor. If you have authentication set up, you also have to have a minimum interval set up in the same hierarchy as where you set it up. So either applying to the whole protocol, applying to the group, or applying to the neighbor. All right, so it looks like nothing came up in that trace file. Let's see if the BFD sessions have changed. And it looks like they're up. I don't see how we can tell if there's authentication on them. Detail maybe. Here we go. Authenticate. So that's very likely enough evidence that it's working. I can always do a rollback 1 on both sides. Oh, yep, and you can see here. So BFD eval initiated. Let's see if it still says authenticate. Nope, that's missing now. Okay, so that's very good. Let's see if we can get Wireshark to work. So the last commit, if that's, so yep, well, I'll just restart GNS, and hopefully that's all it takes. So you can see it actually was started. It just, there was something wrong with my GUI, graphical user interface here, that wasn't showing that it was actually running. And that happens a lot. So I'm kind of glad that was called out in this video because it happens so often. It's like, if you're a new user of GNS, it's really going to throw you for a loop. But usually just a restart is all it takes. All right, so now let's take a look and make sure that it didn't do the bug where it takes away your last one. So nope, that's the last thing I did. So if I do a rollback 1, show pipe compare, you'll see that I'm adding the authentication back, which is what I want to do. I'll just double check on here, show system rollback compare 1.0. Yep. So rollback 1, show pipe compare, perfect. Commit that, commit this, and now hopefully we'll get another message showing up unless it's stopped scrolling, which is of course always possible. Looks like we've got a bunch of BFD messages to dive into. But let's go ahead and, well, I mean, we always can see if it's scrolling or not just through a ICMP ping. So let's do an ICMP ping, filter off our ICMP, and then see if that's what it takes. Ping 10.10.10.1. So right there, you can see, and then if I do a show in descriptions, 000, yep, that's going to A. So yep, for sure enough, it wasn't capturing. So that's one that's kind of frustrating because it typically only captures for a little bit. And when it stops capturing, it's like, ah, you missed all the traffic you needed. And just kind of that it's so fickle is kind of frustrating, more frustrating than some of the other bugs. But hey, I mean, as long as it's possible, this is great. Like, I don't have to go through Juniper or you know, kind of get special access to something. Like, I'm able to set this all up myself, and so it's really not much to complain about in that regard. All right, so I'm gonna roll back 1 on both, commit, and then undo the rollback. Commit, and then I will roll back the rollbacks. And then I will stop the capture and we'll do a deep dive in Wireshark, and then that'll be the end for Bfd for Bgp, and it'll be time to move on to the next topic. And you can see I've got some messages, so here's more. So this should say something about there no longer being authentication on it. And this should say something about authentication being added back in. I guess it doesn't say anything about that, but we'll definitely see it in the Wireshark capture. And for now, you don't have to take my word for it, because you can see in this show BFD session detail command, it is configured to authenticate. One thing that I did want to demo is seeing what happens when this time here, security authentication keychain start time, what happens when that goes into effect. And I believe if you put a expired time, like let's say I'm configuring this today and I set the start time to yesterday, that's basically a way of saying start right now, and it'll start right away. But let's go ahead and dive into that and see what happens if it is not started and then it starts because of the start time. Oops. All right, so we're going to do delete start time on both, delete start time, and then run show system uptime. So let's go for 6:13. So set start time 20:20 04:09.16.13.00. Oops. Oh, and these aren't going to be dots, they're going to be colons. There's just going to be one dot separating the date from the time. So hopefully that gives me enough time to actually see it in action. I think it will. So, oh, actually it looks like it didn't give me enough time. Okay. Well, easy solution to that. Okay, so there's 14. So let's go, instead of 15, let's just go all the way up to 17. It seems to be taking me a lot more time than I kind of have ever estimated. So dot, oh, and it's going to be 9.16.17, oh, 16:17:00. So yeah, I mean, that's going to be plenty of time. All right, so plenty of time to wait. So we can see we're going to be at 15, so it's actually kind of too much time this time. Hopefully it's still scrolling. I actually do have time for a fresh capture, so I'm going to get that. And then we'll see the actual, because we're at 13 right now, but we can go pipe refresh 1. We can see that increment up to, oh, did I set it to 17? That's too far away. It's 14, 3 minutes. Let me see what I set it to. I mean, in that time, I can dig through the Wireshark Capture. So show configuration, pipe display, set, pipe no more. So we've got, let's see here. Yep, so 17. So that's going to be quite a ways from now. But that'll give me time. Well, actually, it looks like there's a discrepancy. So on here, it says it's only 14, but on here it says it's 16. Let's do a show Bfd detail on this side, sessions detail, session detail, pipe refresh 1, and then hopefully we'll see the authenticate. Okay, so authenticate looks like it already went into effect. So system uptime on this side is probably past 17 now, or well, it's not past 17 now. So I guess I don't know why it is already in effect on one side, but not the other. It's kind of interesting. But in any case, I mean, basically, probably just going to see the authenticate keyword pop up. We'll probably see maybe a log message. I guess that's what I was curious about. That's why I wanted to do this exercise. And then we'll probably see a difference here between the packets being authenticated and packets not being authenticated, but we're going to need to wait another minute and a half for that to happen. So you can just take a look at the capture just as it's scrolling. It looks like we're getting a lot of Bfd messages, which makes sense because we set it up to be every 100 milliseconds. So you can see, and it's going to be unidirectional. So your source addresses are going to change. And then I'm getting it for 2 BGP sessions as well. So why don't I just kind of make it a little bit easier to read and just look at them sent from one source, 192.168.6.5. So now we can kind of see more clearly how long they take. So you can see the 205, 8, 9, 6. So definitely less than 1 second. Probably like 0.1 seconds. Yeah, I mean, knowing what a millisecond is in seconds is something that you'd think would be just standard. But the good thing about looking about computers, working in computers, is you've always got a calculator on you. It's just you got to take the time to go and use it, which for something simple like this, if I had just known that 1,000 milliseconds was 1 second, which is what I thought it was, I just wanted to fact check myself. I would have saved myself all that time of going and looking it up. And I wouldn't have had to kind of stop and think if I would just trust that I knew what I was, what I thought was true, if I just trusted that it was true. So, but you can see it's not exactly 1 second. I guess that's why I was questioning myself. I thought it was not going to be 1 second, because you can see just how much faster they're coming too, and they seem to be coming in like pairs. And this is all just from the source address too. So, okay, so I think it has elapsed 17. Yep, it's now on to 18. So let's go back through here and see when it crossed over to 17 and see if there were any messages that popped up. So local clock, here we go, 16, 59, 16, where's 17? So where's 18? 18 is gonna be protocols started, oh, current time, okay. I probably should have filtered that out so it's easy to read. But we're looking for current time, and we're looking for 1700. So current time, 1706, 1701, current time, 1650, 56, current time, 57, 58, 59, 1700. So it looks like there was no trace message that popped up, but oh, and this is interesting too. It looks like there's no second authenticate message either. Oh, but that's going to be because we didn't set it up for that other BGP connection. We just set it up for the one neighbor. So show Bfd session detail. So here we did actually apply it to the whole group. So we set it up to authenticate to the other connection, but where it's actually going to be authenticated is to .4. So let's filter it out through .4. We can stop the capture. I think we've got everything that we'd ever want to see. And then let's look at the ones that also source from the other side of that connection. So this is interesting. It looks like I filtered it out for, oh, I just never hit enter. So there isn't anything sourcing from .4, which is interesting. Oh, it's, yeah, 6.4. So that's the address. So 192, that 163.6.4. Okay, so these are all the packets sourcing from the BGP neighbor here. So from router B. So 192.163.6.4. So everything's sourcing from router B. So let's also take a look at everything sourcing from router A. So show Bfd sessions detail. Show Bfd session details. So, and then it's going to be 192.168.6.5 is going to be the other one because, and we know that because of the authenticate, but not on this one. So 192. .168.6.5. Oh, I thought that's how you could do that. Oh, I misspelled this. There we go. So now I get packets that, let's see here. Oh. It's got to be a or. Yeah, because if it's and, you know, you don't even have two source addresses, so it's just a completely nonsensical filter. It's got to be or. The source address is either this or this. So here's the symbol for or that Wireshark accepts. So let's just look at these exchanges between R1 and between router A and router B. So let's just look at a regular protocol Bfd control. So it looks like these are the only kinds of BFDs. Let's also filter it out for Bfd only for now, just so we can tell if there is some special, yeah, if there is some special extra kind that aren't just all controlled, that'll pop right out to us. It looks like that's not the case. So actually I'm gonna get rid of that, just so we can kind of see what other kinds of traffic is there. So here's the Bfd control message. The message flags: poll, final, control plane, independent, authentication present. Here we go. So this would change from a 1 to a 0, and we can see exactly where it is. It's part of this CC. And if we take out the Notepad++, and we know that this is in hex, so the decimal equivalent of a C is going to be so A is 10, BC, so 11, 12, it's going to be 12. And then we know we've got 4 bits, so we can have 16. So to represent a 12, we're going to have the 8-bit on, and then we're also going to have the 4-bit on. So that's one of our C's, but we've got 2 C's. And of course, you can switch it to binary view if you want. Just show it as bits. Yep, so see how that matches? And it's going to be the specific one for authentication. Looks like, because you can see these dots here represents the actual bits, and then it goes through each dot, and you can see actually the one thing that's kind of interesting is the protocol message. The protocol version is the first 3, but the diagnostic code gets 5 bits. So it's not like everything gets a perfect nibble. If you're looking at only hex and you don't have a good understanding of the fact that it's binary, you might think, oh, it's only significant that this is 0 through F, but that might not be the case, because certain things like the diagnostic code here could have a greater number of bits. So this has 5 bits assigned to this diagnostic code, and then this only has 2, this only has 3. So you might think, oh, it's only significant for 4 bits. Well, that's absolutely not true. You might think that if you're only looking at the hex. That's why I kind of prefer the binary, because there's a lot of things that are just simple switches, is the poll set or not, true or false. And you can see this is this octet. So all 4 of these are going to be used. So the other thing you can see, and let me select it here. Yeah, so we've got 1, 2, 3, 4, and then you can see here's, so we're not talking about 1 octet here, we're talking about 2 octets. And here's the next octet, and then here these dots represent the next bits. So it's kind of, if you're looking at it for the first time, what are all these 1s and 0s and dots? It doesn't make sense, and then something like this could really confuse you. But I think it's, if you really understand networking and how the bits work and binary and all that, and you kind of did your drills to learn subnetting, I think this is like absolutely intuitive, a really great way of listing out all the bits. I think this is a really excellent tool. And now you can see when I click on this control plane independent, well, it's because it's going every but here we go. So if I switch this over to hexadecimal, hexadecimal. Oh, well, never mind, because it has 2 of them. Basically what I was getting at is, and I can actually kind of show what I was getting at. So if I come up here and I'm looking at this one, now I move over to the next one. So I was expecting it to kind of move over to the next one from here to here, but that's only if it highlights every 4 bits, as I was kind of expecting it to do in hexadecimal. But in hexadecimal, it, instead of highlighting every character place, it highlights every octet. So, but here's what we got, our authentication present. That's basically all we need to know. And then a bunch of extra things. Here's how we can tell that it's keyed SHA. There's a checksum. So I don't see the actual key, which is probably a good thing. But this is how it could be used for that attack, why it's important to sometimes, instead of just having a keyed SHA, it's important to also have a one where the sequence numbers are tracked. And I forget what that's called, but we'll find out. Let's go ahead and enable that and see how this packet changes. We might be able to see the number. So here's a sequence number. That's kind of interesting that that is included there, even though it doesn't have that extra layer of security attached to it. But yeah, so that was interesting. I think they're all going to be the same pretty much. Yeah, except for like the sequence number and the checksum are going to be different. I think I did have some where I had authentication not enabled. So let's go through and see if we see that bit flip off for some of them. Yeah, so let's go through and see if that bit changes for any of these. So yep, it's going to be set for all of them. So it looks like I don't have that. I can roll back the commits. I do have a lot of packets. I mean, it's going every second, but it's obviously going a lot faster than that. So it's just kind of good to know that when you set up BFD, yes, you'll get near instant failover, really fast failovers, but you're going to get a lot of control traffic on your network. And I guess 94 for length isn't too bad, but it kind of is. I mean, a TCP looks like there's an ACK that's only 66. BGP keep alive messages, let's see, those are only 85. So yeah, these are kind of big, a lot of bits and very rapid. So it's always a bit of a trade-off. That's another thing I'd like to do is have bandwidth utilization be kind of more of a feature of what I'm doing here. It's really something I've kind of let fall by the wayside, focusing more on packet capture, but I can certainly focus on both at the same time. I mean, you can see utilization just using the command line. You can see traffic statistics, but even that doesn't really, I mean, here's your bits per second. So if it's a gigabit Ethernet, you know what your max is. If you're getting up there, you're over like utilizing the link. But I mean, I like to have the percentage utilized, which you can probably get with some special tool like SolarWinds Link Monitor or something like that. So it might be worth having that set up just to have a better understanding of what the things are in the real world that are going to be important to pay attention to, especially if you're enabling a chatty protocol like this. All right, so one final thing I want to do is I'm going to keep these packets. I'm not going to save them necessarily. I'll just take a screenshot of what it looks like. And then I want to set up a different kind of authentication, one that has that extra security built in. Oops, and it looks like I got my own. Here we go. So I'll just move this out of the way and then take a clean one. There we go, perfect. So now I will restart the capture. But I will, before doing that, I will get the BFD configuration changed. So set authentication keychain. Here we go. So this is going to be different now. we're going to set it, instead of keyed SHA1, we're going to do meticulous keyed SHA1. That word was escaping me. I knew kind of the concept, and this is kind of the running theme of this channel. Like if you know the concepts behind it, you know what it is. Oh, it's just for tracking the packets so that you know if there's a break in the order or something, then there could be malicious activity happening. If you know that, you're much better off than if you just know the word meticulous, because it doesn't even tell you what meticulous means in the description, so you don't have a clue for that. But you know there's only one other option besides keyed, and that's meticulous, so you know that's the one you're looking for. And meticulous kind of makes sense as a word to use because you're meticulously, carefully keeping detailed records of the order of the packet. So, all right. So yeah, that's one of the main themes of the channel, is learn the concepts, and the actual things you need to type in will just kind of take care of themselves. So, yep, so here's meticulous. Oops. And, okay. So cannot be configured without a keychain. So I need to set up a keychain. So let me go edit protocols, BGP group, internal peers, show pipe display set relative, so it's all nice and clean. And now I get a keychain Bfd Bgp. So let's take a look at that. Show pipe display set pipe match Bfd Bgp. Huh, that's interesting. I have a keychain, at least on this router. Maybe it's gone on this one. Nope, I have a keychain on this one as well. So I don't know why this is saying I can't have a keychain. May not be configured without keychain. Well, keychain's right there. Huh, okay, well, that's interesting because you can see I do have a keychain. Maybe the keychain needs to be different, because the secret is probably not in SHA encryption. Oops. So let's do set secret. So there's the key. Yeah, so it probably got encrypted. Well, let's try it. So delete secret, set secret. It's a secret, and maybe this works. Nope. Algorithm meticulous keyed SHA1 may not be configured without keychain. Okay, well, we've got a keychain, so it's not that we just don't have one, it's that it's not being applied to this somehow. Oh, and it looks like this actually went away now. Like it's not even meticulous anymore, but it's saying that it is. Let's see here. So yeah, I don't even see it. Oh, okay. So this makes sense. I applied it to the group and not the neighbor. So yeah, really good thing to happen to me in the lab. Just kind of a better understanding of the kind of what can go wrong in the CLI, and hopefully that doesn't happen on the actual exam. So I'm going to do edit and then delete algorithm keyed SHA1, and now set algorithm, and it's going to be meticulous keyed SHA1. And one thing I'd like to do is set that key back to what was in the example, because I'm going to need to change one side. They have to match, but I might as well just reuse what was in the example. So it looks like it is a different kind of hash now. It's $6 $. But oh, sorry, that's for the encrypted. Okay, so it's still $9 for this hash. Okay, so let's see here. Edit, delete, secret, set, secret. You don't need to look it up. Here it is, already highlighted. Enter. Top, commit. Perfect. So now that it's in the right hierarchy, I think there was an issue on this side as well. Nope. So now it's set to meticulous on both sides. So hopefully we'll see differences in those packets, and we'll be able to put it side by side with that screenshot and see how it looks different in Wireshark once meticulous is enabled. Meticulous keyed SHA or MD5. Once that's enabled, we'll see how it looks different. So we've got here we go. So here's one big difference. It says just right there, meticulous, whereas it doesn't say that there. And then we've still got an authentication key ID. We still got authentication type. It looks like it's a different authentication type now. But that's really the only difference I see. I mean, I don't see the extra, like, meticulousness that counts the order of the packet. Yeah, I really don't see that anywhere. You notice it's UDP. Yeah, I mean, I don't really see that. You can see that it's different here, but I don't know, maybe it just doesn't use the sequence number here, but it uses it here, but it collects it regardless. So it's not a matter of whether or not it collects the sequence number, it's a matter of whether or not it actually uses it for anything. It could be that. But I think that's probably good enough. I guess there's one final thing I'd like to look at, and that's what happens when I kill the BGP session and restart it. So I'm going to do that right now. So exit. Oh, and here I got a bunch of BGP messages. But let's go ahead and clear BGP neighbors all. And now I'll see much more. And I'll see the 4-way disconnect. And I'll see the 3-way handshake. 4-way disconnect, yep. FINAC, ACK, FINAC, and then BFD got in the middle, ACK. It's interesting, BFD is actually still going, even though the disconnect happened with BGP. It's still able to send BFD packets, but it's just, so it's sending it from both sides. You can see .4 and .5, and from the other connection. But you can see it's saying that it's admin down. So this is interesting that it says no diagnostic state up. That's kind of interesting. That's probably to, well, no. Huh. Oh, okay. Yeah. So this is to the 40.4 because there was a BGP connection directly from here to here. So if I kill the BGP sessions on here, BGP is just transparent traffic going through router B when it comes to the neighborship between A and C. So it doesn't matter what I do. I can delete BGP completely off of the device on router B, and I'll still have a connection from router A and C because it's just passed transparently as TCP traffic through router B. So you can see that the state of BFD between A and C was unaffected by clearing the neighbors on router B. But of course, the neighbors between router A and B and router B and C, those were admin down. Looks like we got a OSPF hello packet in there. But lots of BFD, you can see just how chatty it is. I mean, you got to make that decision. Is it worth having really fast failover times for kind of reduced capacity on your links due to all this chatter? Well, you know, this is where it's a kind of a good idea to have those tools set up that really tell you your utilization, and then you can make those calls. Unfortunately, the only tools I have to do that are the what's on the device, monitor traffic, or not monitor traffic, monitor interface 000. And then even that, like, this isn't really useful information. It's just input output per second. So really kind of when it comes to making trade-off decisions like that, you might want a more robust tool than just what you see on the interface here. All right, and it messes up your CLI too when you use it. It's really not one of my favorite commands to use, but unfortunately it's kind of all you got. Show interface G, oops, zeros. So, I mean, I'm sure there's other tools. Like you can kind of see it, input rate, output rate, but definitely setting up like a link utilization monitoring software like SolarWinds, I think comes with GNS3. I just haven't set it up, but having something like that running is definitely what you'll have when you go into a production environment. There'll always be something like that. So, or if not, hey, you've got the opportunity to set it up. All right, so I think that's pretty much it. So we looked at, so let's look at the handshake. So SYN, SYNAC, ACK, here's, and then the open message, of course. So now we've got BFD. Yeah, it looks like there's no authentication on this one. So we see that's toggled off. So this must be between A and C then, or sorry, this must be between B and C. So it's going to be to the .40. Yeah. So 6.5 to 2.40. Yep. The ones without authentication. Yep. And here's the BGP notification, which is going to be introducing new routes. Or sorry, it's the connection collision resolution. Oh, this is interesting. So this is what happened last time that we saw, where it did a three-way handshake, but it actually failed because of this connection collision, and then it had to do another three-way handshake. So it does a, let's see here. So SYN, SYNAC, ACK, and then BGP open message. But something happened along the way where it wasn't able to actually work. So it gives a notification message saying connection collision resolution. And then it does a FINAC ACK. And I believe from there it does the full sign off. But of course, what we can always do is look at this, and then if it did do this full sign off, it'll be the last thing in the stream, because we can always follow the TCP stream. And at the very end, nope. So it looks like it's just sending keep alive messages. So it is going good. And of course, what you can always do, anytime you've got any question at all, might not always get the right answer, but you can go ahead and say, because in this BGP notification, okay, so connection rejected, but so that's interesting for that one. And it's interesting that there's no other three-way handshake in there, but it might just need the one, and then it will work itself out. But here's the four-way disconnect. So three-way handshake is going to be up next. Here it is. SYN, SYNAC, ACK. SYN, SYNAC, ACK. Okay, so I was probably following the wrong one. It looks like there were multiple. Yeah, so this is the one where it wasn't successful. And then one thing I can even do is mark this packet and then go back. And then now this packet is still marked in here. And you can see that, okay, so this SYN, SYNAC, ACK is sourcing from a different device. So that's a whole different one. And then, I guess I'm surprised. Yeah, I would have thought that if that first one failed, there'd be another one for that, but I guess it's not relevant to BFD. Let me go ahead and follow the stream again. Kind of finish that thought I had, where kind of a recommendation is something you can always do. A big advantage you have working on computers. So connection collision resolution for BGP notification message. So if I want to know what that is, just go right to Google. BGP notification connection collision resolution. Yep, and now I've got any number of links to choose from. I always recommend opening up 2 or 3 at a time, just because you don't know what kind of answer you're going to get. More authoritative source, the better. There's nothing more authoritative than the RFC. So, and a lot of people are afraid of RFCs, but don't be. They're written by people who want you to understand what they're saying. So RFCs are actually going to be a pretty good resource. It's not going to be buried in technical jargon, things that you can't understand and figure out, they're going to be very clearly written, because the point of it is to introduce something that they want people to use and understand. So, okay, so here's the subcode. Well, looks like there's just not that much information about it in this particular RFC, though. I mean, that's something that, you know, the educational resources are, of course, educational resources. So if you're trying to get educated about something, it's probably your best resource. I think RFCs are requests for communication. It's meant for communication between engineers. Yes, they're trying to introduce something that they want people to use or comment on, so they're going to be clear in it. But are they trying to educate you? You know, not so much. So if you're looking to be educated, yeah, educational resources are more of what you want. But here, the educational resource I found is just quoting the RFC. And it's not the one I was looking at, but all right. So BGP connection collision detection. In a pair of BGP, if a pair of BGP speakers try to establish a BGP connection with each other simultaneously, then two parallel connections will be formed. Okay. If the source IP address used by one of these collisions is the same as the destination IP address used by the other, and the destination IP address used by the first connection is the same as the source IP address used by the other, collision detection has occurred. In the event of collision detection, one of the connections must be closed. Based on the value of the BGP identifier, a convention is established for detecting which BGP connection is to be preserved when a collision occurs. The convention is to compare the BGP identifiers of the peers involved in the collision and to retain only the connection initiated by the BGP speaker with the higher valued BGP identifier. So yeah, and this looks like a race condition, they're saying. So, but you can set one to passive to always be the one that is allowed to initiate. So this kind of clarifies, because in a previous video, I saw this, I saw this behavior of both sides trying to initiate. And I thought, oh, well, maybe the reason for this is that you actually need a handshake for BGP one way, a handshake for the BGP other way. But no, I can see very clearly from reading this. So I'm really glad I looked into this deeper. What's going on is that neither device was told which device is meant to initiate the BGP neighborship. So therefore, they both try to initiate the neighborship. And if they both, so if while you're trying to initiate a neighborship, while I'm trying to initiate a neighborship with you, if you then try to initiate a neighborship with me and your source address matches the destination address I'm using, then that's a collision. So yeah, and the destination address used by the first connection is the same as the source address used by the other. So I'm contacting you with a destination address, you're contacting me, but your source address is the same as the destination address I'm using. That's a collision. Both of us know, oh no, we're racing, we're trying to compete with each other to see who gets to initiate this. Well, let's look at some attributes about us and then decide based on those attributes which one of us get to initiate the connection. And you can see it's going to be the BGP identifier, so that'll be in here somewhere. Here we go. And it's going to be the one with the lowest identifier. So we've got .4 as an identifier, and we've got .5 as an identifier. So .4 is going to be the one that works. So all of these, so this one, which was initiated by .4, because you can see the source port is going to be ephemeral on this. This one says, well, let me see if it's, so the convention is established for detecting, the convention is compare and retain only the connection addition with the higher value. Okay, yeah, I thought it was the lower, but yep, it says it's the higher. So this one, initiated by the lower value, .4, says, oh, we're both trying to do this, but I see your identifier is higher than me, so I'm going to gracefully close mine and let you establish it with you sourcing it. So you're going to use the ephemeral, I'm going to use the well-known, and that's because you have a higher BGP identifier. So here's the packet I marked where that happened from .4, and .4 says, oops, sorry, like you've got the higher one, okay, you can have it. So the one that went through from .5, which you can see happened at pretty much the exact same time, milliseconds apart, this is the one that actually makes it through. And if I follow the stream, you can see we've got even keep alive. We've got no fins like we did in the other one, because it's not gracefully saying, oh, okay, you've got the higher BGP authentication, you can establish it. So you are for sure going to have only one BGP connection between two devices. It's just whichever one it sources from, you can either manually configure that by using the passive keyword and say that I will never initiate it, I will only wait, and then if it's initiated to me, I will allow that. Or you can have them both try to initiate in a race condition, and then as long as the destination and the source matches, it'll detect a collision, as we had saw there, which we'll see here as well. There should be a notification in here even saying that there's a collision. I think. Well, I guess I'm surprised. Oh yeah, in this update probably. Okay. Guess I'm surprised there's nothing like that in here. But anyways, that's why that one had all the spins in it. It's because it had a lower BGP identifier. So that's good to know. I didn't even know that. I was actually really wondering about that. If you look back at my old videos, I was kind of coming up with conjectures on what that could be, but I found the truth today, and I guess I'm set free. So I think that's the end of this, of this video. It looks like there's some verification commands they wanted me to do that I haven't done yet, so I'm going to run those. I've already been running this, and it points out the authenticate. I haven't run the extensive command yet, so I'm just going to run that quick on all of them. And then that'll be the end of the video and the end of this topic, which is good news. But show Bfd session extensive. This will give me more details. And yep, I'm using algo meticulous. Not sure what that means. Mode loose, they're using strict, but I'm allowing it if it's to not restart the session and just use authentication. So, and you can see there, yep, I'm doing that for both, but if I do it here, because I applied it to the neighbor and not to the group, you're gonna see it's quite a bit different. I've got the authenticate, but on my second one, I've got nothing like that because it's not enabled there. All right, so thanks for watching. That wraps up the topic BFD. So it's time for the next topic in the next video. So hope to stay tuned, and thanks for watching.